Welcome to this scientific lecture where we explore a powerful framework, treating your everyday life as a laboratory notebook. Today we will examine how reframing daily activities as experiments can accelerate your personal growth and innovation. Let me start by asking a fundamental question. What if every decision you make could be structured as a scientific experiment? The answer lies in understanding that the scientific method is not confined to laboratories. It is a universal framework for learning and improvement. By systematically forming hypotheses, collecting data, and analyzing results, we transform subjective experiences into objective insights. Let us establish the core framework. Every experiment in your life notebook consists of 4 essential components. First, the hypothesis. This is your testable prediction. For example, if I wake up at 6 a.m. instead of 8 a.m., I will complete 20% more work by noon. Second, variables. The independent variable is what you control, like wake time. The dependent variable is what you measure, like work output. Third, data collection. You must measure consistently. Use quantitative metrics whenever possible. Track sleep hours, productivity scores, mood ratings. Fourth, analysis and iteration. Examine your data, draw conclusions, and refine your next experiment based on what you learned. Let me walk you through a concrete example. Consider your morning routine as an experimental system. Here we see the experimental design. Our hypothesis is that early wake time increases productivity. The independent variable is wake time, ranging from 6 a.m. to 8 a.m. The dependent variable is number of tasks completed by noon. We control for sleep duration and meal timing to isolate the effect. You might ask, why do we need control variables? The answer is scientific rigor. Without controlling for sleep duration, we cannot determine if productivity gains come from wake time or simply from being more rested. This graph shows our experimental data over 14 days. The red dashed line represents our baseline productivity at 8 a.m. wake time. The green curve shows actual performance when waking at 6 a.m. Notice the upward trend indicating a 30% improvement over the trial period. Now let us examine the architecture of the feedback loop. This is where the real power emerges. This diagram illustrates the continuous feedback loop. You observe a pattern in your life. You form a hypothesis about how to improve it. You run an experiment to test your hypothesis. You analyze the results. Then you observe again with new insights, and the cycle repeats indefinitely. An important question emerges. How fast should this experimental cycle run? The answer depends on your domain. For habits like sleep or exercise, cycles may be weekly or bi-weekly. For creative projects, cycles might span months. The key is matching cycle length to the timescale of meaningful change. Let us examine a second example. Optimizing your study schedule using experimental design. The hypothesis. Spaced repetition across multiple days produces better retention than cramming the same total hours into one session. We designed 2 conditions. Group A uses mass practice, 6 hours in 1 day. Group B uses spaced practice, 2 hours per day over 3 days. Total study time is identical at 6 hours. This controls for effort investment. The results are striking. Both groups show exponential forgetting curves, but the decay rates differ significantly. The red curve represents massed practice with rapid initial forgetting. The green curve shows spaced practice with much slower decay. After 30 days, spaced repetition retains 40% more information. Now we must address complexity. Real life involves multiple interacting variables. The question is, how do we handle systems where many variables interact simultaneously? The answer lies in factorial experimental designs. You systematically vary one factor while holding others constant, then repeat for each factor. This table shows a factorial experiment on productivity. We test 4 variables each at 2 levels. Sleep shows a plus 15% effect. Exercise shows plus 22%. Caffeine shows plus 8%. Interestingly, background music shows minus 5% for this individual. These are personalized insights from systematic testing. This brings us to a crucial insight. The power of n equals 1 experiments. Traditional science requires large sample sizes to establish general principles that apply to populations. But personal experiments optimize for you specifically. Sample size of 1 is perfect when the goal is individual optimization, not population inference. Let us examine project management as an experimental domain. Hypothesis. Using strict time boxes for tasks increases completion rate compared to open-ended scheduling. We set up two conditions over alternating weeks. Control weeks use open-ended task scheduling. Work until the task is done. Experimental weeks use strict 90-minute time boxes with forced breaks. We measure tasks completed per week. The bar graph shows alternating weeks. Red bars are control weeks averaging 10.5 tasks completed. Green bars are time box weeks averaging 15.5 tasks. That is a 48% improvement. The constraint paradoxically increases output by preventing perfectionism and decision paralysis. A critical challenge in life experiments is quantifying subjective experiences. How do we measure abstract qualities like happiness, energy, or creative output? We use validated psychological scales and proxy metrics. For happiness, use daily ratings on a 1 to 10 scale. For creativity, count novel ideas generated. For energy, track hours of focused work sustained. This table shows operationalization strategies. Mood is measured 3 times daily on a 1 to 10 scale. Energy is quantified as total hours of focused work per day. Stress can use physiological proxies like heart rate variability. Learning is assessed through weekly retention quizzes. Now we arrive at the most powerful insight, the compound effect of systematic iteration. Consider this exponential growth equation. Y equals y sub 0 times the quantity 1 plus r raised to the power n. Y sub 0 is your baseline performance. This is where you start. R is your improvement rate per experimental cycle. Even a small value like 0.01 or 1% compounds powerfully. N is the number of iterations. The more experiments you run, the higher the exponent. These curves show compound growth at different improvement rates. Green shows 2% per cycle. Yellow shows 5%. Red shows 10%. After 50 cycles, 2% improvement yields 2.7 times baseline. 5% yields 11.5 times. 10% yields 117 times baseline performance. This is the mathematics of systematic experimentation. Let us now discuss practical implementation, building your actual lab notebook system. First, choose your recording medium. Digital spreadsheets work well for quantitative data. Written journals capture qualitative observations. The key is consistency. Second, define metrics before you begin. Pre-commitment prevents post hoc rationalization. Decide what success looks like before collecting data. Third, set appropriate durations. Too short and you miss meaningful patterns. Too long and you delay iteration. Most behavioral experiments need 7 to 21 days. Fourth, document everything. Failed experiments teach as much as successful ones. Negative results are data, not wasted time. Fifth, schedule analysis sessions. Weekly or bi-weekly reviews where you examine data, draw conclusions, and design the next experiment. Here is a sample lab notebook entry. It documents date, experiment name, hypothesis, methodology, measurement approach, duration, results, and conclusion. Notice the final line, next experiment. Every conclusion generates a new question. This is the cycle in action. Let me address common pitfalls in personal experimentation. Pitfall 1. Changing too many variables at once. This confounds your results. You cannot isolate causation. Solution. Change one factor per experiment. Use control periods for comparison. Pitfall 2. Confirmation bias. Seeing patterns you expect rather than what exists. Solution. Write hypotheses before data collection. Have someone else analyze your data if possible. Pitfall 3. Too few data points. 1 or 2 days is not enough to see patterns. Solution. Minimum 7 days for most behavioral experiments. 14 to 21 is better. An advanced technique is conducting meta-analysis of your experiments. After running 5 to 10 experiments, analyze patterns across all of them. Which interventions show consistent effects? Which are context-dependent? This scatter plot shows effect sizes from 10 different productivity experiments. Yellow dots represent individual experiment outcomes. The green dashed line shows the mean effect of plus 14.4%. Note experiment 5 showed a negative 3% effect. That is valuable information about what does not work for you. Now we arrive at the acceleration principle. Why this method compounds learning speed. Traditional learning is essentially random trial and error. It is linear, at best, often circular. Experimental learning is systematic. You document what works. You build on successes. You avoid repeating failures. Consider this kinematic equation. V equals versus sub-zero plus A times t. V is your current velocity or skill level. A is your acceleration from systematic experimentation. T is time. With constant acceleration, your learning velocity increases linearly with time. Red line shows traditional linear learning. Green curve shows experimental learning with positive acceleration. Both start at the same baseline. By month 12, experimental learning achieves nearly double the skill level. This gap widens over time. Let us examine real-world domains where this framework excels. Physical fitness. Experiment with workout timing, intensity protocols, macronutrient ratios, sleep schedules. Measure strength gains, body composition, recovery time, energy levels. Creative work. Test different ideation techniques, work environments, time allocations, collaboration patterns. Measure ideas generated, quality ratings, project completion rates. Relationships. Experiment with communication styles, scheduled quality time, conflict resolution approaches. Measure satisfaction ratings, positive interaction frequency, conflict resolution time. Skill acquisition. Test study methods, practice schedules, feedback mechanisms, teaching others. Measure retention scores, performance on tests, speed of improvement. An important question. Can we experiment with everything in life? Some domains have constraints. Relationships involve other people who are not experimental subjects. Major life decisions like career changes have high switching costs. Use judgment about what to experiment with. Let me paint the long-term vision of this approach. After 1 year, you have completed 12 to 50 experiments depending on cycle length. After 5 years, 60 to 250 experiments. You now have a massive personal database. The result is not just improvement. It is deep self-knowledge. You know precisely what works for you. You have optimized systems across all life domains. This is your life after years of systematic experimentation. Every major domain has been optimized through data-driven iteration. Sleep patterns dialed in. Exercise protocols proven. Work systems refined. Learning methods maximized. This is not theory. This is engineered excellence. Let me synthesize everything we have covered today. Treating life as a laboratory reframes failure. There are no failures, only data points. Every outcome teaches something. Systematic iteration creates exponential returns. Small improvements compound into transformative change. Documentation enables meta-learning. You learn not just from individual experiments, but from patterns across all experiments. This method accelerates both learning and invention. You learn faster about what works. You invent new approaches through systematic exploration. In conclusion, your life is the ultimate laboratory. Every day presents opportunities for experimentation. Start small. Pick one area of your life. Design one simple experiment. Run it for 2 weeks. Document everything. Analyze results. Design the next experiment. The compound returns will transform you. Not through willpower or motivation, but through systematic empirical optimization. Science is not confined to laboratories with white coats. Science is a mindset, a methodology, a commitment to evidence over intuition. You are both the scientist and the experiment, the observer and the observed. This dual role gives you perfect information and perfect control. Begin your first experiment today. Open your lab notebook. Write your hypothesis. Define your variables. Start collecting data. Welcome to the laboratory of your life.